In a previous video I started building a column speaker to use as a stand for a touchscreen. I built the box and picked out sound drivers I liked. Also I talked about the crossover design. So now let's put in an amplifier, finish up the box and start adjusting those ports for good bass response and hear an unexpected result. So this speaker has to be active, that means having an amplifier inside the box. First I thought about using the amp from these little guys. And yes, it's totally underpowered for all of those drivers I picked for the speaker. But here's why I really wanted to use that. It has a sound sensor that turns on the power when an audio signal is received. I need a system like that because the speaker will only play sound from my smart home control panel, this touchscreen here. So all of that audio content will be automated. That means that I need an amplifier that would turn on automatically when receiving sound from this touchscreen device. But as you may guess, this little amp was a piece of shit. It didn't have enough power for all of my drivers, so I was forced to think about other options. I tested a soundbar amplifier, but because it's a 2.1 system, it had a built-in crossover, which I could not override. Also, it could only work automatically when the sound came in through the digital input. And unfortunately, in my case, I can't use that with a Raspberry Pi, which is running this touchscreen. Find the video about making this touchscreen in the description. That's how this whole project started. So next, I decided to use an amp that originally was driving those woofers I chose for my speaker. And it worked pretty well. But now I had a challenge with how to activate this amp automatically. First I thought about just keeping it always on. It only consumed 2.5 watts, but being always on would be very bad for the amplifier IC. So I just had to add something to this mix, and this is what I added. This is a $5 Wi-Fi switch that I will integrate into my smart home system. And it only consumes 0.7 watts, which is 3 times less power consumption than if the amplifier would be always on. I actually have a video on how useless this device is, but here I'm kinda debunking myself since finally I found some use for it. Find that video also in the description. I curse a lot, it's kinda funny. And please subscribe to my channel right now. So with this device I will be able to turn this amplifier on through my smart home system. But I had to do some hacking, since I needed to control it electronically and not just cut power with a relay that this Wi-Fi switch has. Because on that amp, cutting power created some clipping and weird noises. So I used an optocoupler. With this little awesome component, I can control a pin on that amplifier IC that turns the amp on and off. And it's a really simple circuit. Here it is. You can also use this component on one system to switch anything on another system. You know, when you have two different circuits with different voltages and you cannot mix those circuits in one. Also, I extended a button that this Wi-Fi switch has to be able to control the amp with a button if someday I needed to. I will place that button on top of the speaker and it will be hidden behind the touchscreen. That button can actually be used to do anything in my smart home ecosystem. So it's a good idea to have it exposed since I'm now using a Sonoff anyways. Next, it was time to mount all of that inside the speaker box. I removed all unnecessary parts and enclosures to save space inside the box. I will attach everything under the top plate of this speaker. And yes, I will leave a possibility to open the top and the bottom plates for servicing. To attach all those modules to the plate, I just used some random long screws I found and some spacers I cut from a plastic tube. This way, all those modules will be slightly raised and have air circulating around them. And later I will add another module, the power supply for the touchscreen assembly. So this whole speaker column will have only one wire coming to it at the bottom end, the mains power. Next I made some holes for the audio wire pass-through, for the button, and a gutter for wires between both speaker chambers, since this is a real stereo box with separate chambers. And this is what I got. Now I was finally ready for actually testing the sound. I was waiting a long time for it. But first I needed to finish up the box. Now I don't think that stuffing a speaker with some fluffy material is actually a good idea, cause it's proven to reduce bass response. But you really should do something about unwanted sound reflections inside the box. So I used this material to cover all surfaces inside the box. This is some old dusty air filter material. I found a shitload of it in a dumpster, and it's just perfect for this job since essentially it's more air than material, which means it will damp reflections but won't reduce much of the air capacity inside the box, which is important for bass, because I like bass. So I took the box apart and attach this material with a stapler on all surfaces inside the box. This will have a big effect on sound and keep the bass response at maximum. Next, I reassembled the box and this time used glue to seal everything airtight, except the top and the bottom plates. I will use some laminate floor underlay for sealing that. It's a pretty good material for that and I have a lot of it laying around. Next, I marked holes for driver screws and pre-drilled those. This is a good practice to do to avoid any problems with screwing those small screws and maybe even damaging the drivers while you do it. Believe me, that happens. Now I was finally ready to hear this thing for the first time ever. And one of the channels died on that amp. I was kinda upset, but shit like that happens when you mess with electronics. Anyways, I needed to find a new amp. And this time I decided to kinda make my own amp. I found this nice little active speaker in a dumpster and it had some quality parts inside it. Just look at that crossover. So I checked what kind of an amplifier IC this system had inside and it was just perfect for my needs. It had enough power and it was super simple to set up. The datasheet actually had a typical application circuit, so I found some components for making that circuit. This is all I needed, just some basic caps, resistors, a fuse, and a potentiometer for controlling input level. So I put this thing together and it worked great. Look how those drivers move. Very good sound, no clipping on startup, just perfect. But I had to find a suitable power supply since some power supplies I've tried on this amp created weird clipping noises. I ended up using just a very basic 12-volt power supply that is rated at only 1.5 amps. That was enough. If you are looking for an amplifier chip like that, this is how you may get that for free. This is an old car stereo. Probably was the top of the line back in the days. And it has a nice amplifier chip inside it. It's very similar to the one I used. You can use a chip like that to create a pretty good and powerful amp. So look out for those old cassette car stereos. They usually have just the right kind of amps inside them. Anyways, once again I put everything together and finally started testing this thing. So let's listen to the sound. You should really put your headphones on. So let's hear this thing. I don't have a fancy microphone to record this, so I'm gonna use a mobile device. That's gonna give you a pretty clear understanding of how this thing sounds. Good sound actually, and I don't have ports now in there, just holes in the bottom. I'm gonna make those later and make the bass work a little bit better. But I'm pretty surprised how well this kicks. You know, it's all because of this big box. Pretty nice sound from small drivers like that. Anyways, let's continue with the video. So, I needed to do some work with those bass pods. The objective here is to adjust the bass response to the frequency I like, yeah, me, and that actually works with this whole setup. So I'm going to use just some PVC pipe I have picked up from the dumpster. I think this is meant for bathroom plumbing. The diameter of a round pot, also called a vent, should be at least a third of the bass driver's diameter. So this is just perfect, it's almost half. But note that the wider you go, the longer the pipe must be. Now I'm not using any software or fancy measurement equipment to calculate the size of the pot I need. I'm gonna do it by listening. Yeah, I talked about that in a previous video. I kinda have a point there, so check it out in the description. So first I made just straight pots of 20 centimeters, which is around 8 inches. I installed them listened and decided to make flares on both ends. That's because I really wasn't feeling any air movement and the speaker actually sounded like it was a closed box. Before I put those pipes in there, the air in fact did move through those holes pretty well. So I needed to make sure, is this size just going for a too low frequency or is it just the absence of flares that creates this effect? For making those flares, I found a glass bottle with a suitable profile. Heated up one end and made a flare. You can also say that it's more like a taper rather than a flare. Anyways, I sanded those ends smooth, installed them in, made the other end the same way. Heat gun is at around 200 centigrade, that's around 400 Fahrenheit. But before that, I worked out those holes to match that flare profile. Later I would find out that that task was the most important one. Keep watching. And this is how they look when ready. Not perfect, but pretty good, considering that all of that will be hidden behind a fabric. So I listened again, and yeah, that length was too much. It really sounded like it's a closed box, that means without ports at all. I tested that by closing those holes with my hands, opening, listening, and not hearing any difference. And the air just wasn't moving, so it was definitely not working. And I did the whole job once again. Kind of a hassle, but it's actually faster than trying to calculate all the variables and everything. That's actually kind of impossible, I think. That's why I do it like this. This time I made them 12 centimeters long. That's around 5 inches. And I decided not to do any tapering flaring on the inside end, since I've recently read that it may not have any difference at all. And same effect. Then I tried these little guys, and they kind of make the kick go away, which was not what I wanted. Then I realized that I have actually created a speaker box that is very similar to what's called a transmission line box. Usually it looks something like this, and there are no ports, well, no pipes. Kinda acts as a big pipe itself. But my version was just a straight one. Apparently making bevels on those pipe holes was just what I needed to make this sound good. And that whole diameter was actually the thing that controls the frequency. So, I will keep it just like that without the pipes. Let's listen to it again. I will play another free track from the YouTube library. I've picked this track because it has a good and balanced highs, mids and lows. And there is a lot of space between sounds. It's dynamic, which makes it easier to hear how the speaker actually performs. So, put your headphones on for this. Sound actually now. I'm not gonna do anything to this anymore. But this is not over. I need to mount my display on top of here, like somehow nicely. And I need to make this whole thing look nice and rounded and white. So, subscribe to my channel to see my next video about this project. Please like this video. Thanks for watching.